Hello students. Now in this lecture we will discuss about common emitter hybrid model. Hybrid model is a standard model which is used to analyze the transistor amplifier. We know that in BJT there are three configurations: common emitter amplifier, common base amplifier and common emitter amplifier, common collector amplifier. So let us study common emitter hybrid model, common emitter H model. We know that there are standard two equations. If we understand these two standard equations and standard hybrid model, what are the two standard equations? We describe the hybrid parameters. V1 equal to HI1 plus HRV2, I2 is equal to HFI1 plus HOV2, which we discussed in one of the lectures in hybrid parameters and hybrid model, where HI, HR, HF, HO are respectively hybrid parameters as input impedance, reverse voltage gain, forward current gain and output impedance for any general purpose two-port network. Let us apply this concept into common emitter amplifier. We know that common emitter amplifier is also two-port network where emitter remains common. This is emitter terminal in the equivalent circuit we can see, and this is collector and this is base. Base becomes input terminal, collector becomes output terminal. So there are two ports. One is between base and emitter, second is between collector and emitter. So what is V1 in this case? VB. What is I2? IC. What is I1? IB. What is I2? IC. And therefore these two equations can be written for common emitter amplifier as very simply VB, that is V1, IC, that is I2. And what is I1? IB. See that. And what is V2? VCE. And we have added only one subscript, E, E, E and E. Why? Common emitter amplifier. HIE is input impedance. We can see HIE is VBE divided by IB, VCE equal to 0. Input impedance with output short circuited. What is HRE? HRE is, we can see that VBE divided by VCE. There also in the equation we can see VBE divided by VCE, IB equal to 0. What is this? This is reverse voltage gain. We denote it by HRE. Similarly, HFE, IC upon IB. What is this? Forward current gain, output current divided by input current with VC equal to 0. HOE is output impedance for common emitter. E for common emitter. That is IC divided by VC. IB is equal to 0. Now, in some of the literatures and some of the books, you can also find that delta VB divided by del IB keeping VCE constant. Now, is there any difference between this concept and that concept? No, not at all. These two equations I can write in different way also. How? If this V and I all have been written in capital letters, we use small letters normally for time varying signal. These are here the, we can say, fixed value, DC value. So we take VB divided by IB. So these are fixed value, not time varying. It's not, the signals are not time varying. So what we have done, VC equal to 0. If the signal is not varying and its value is 0, is same as if the signal is varying and we keep that particular value constant. Here VC equal to 0, here what we write? Keeping VC constant. So there is no scope of confusion. Whenever, dear students, whenever there are small letters, we have to understand that delta VB divided by delta IB keeping VC constant is same as VB divided by IB, VC equal to 0. Similarly, VB divided by VC, IB equal to 0. If you read standard book of analog electronics authored by Milman Alkias, you will find that these are the smaller case letters which are used for, defining hybrid parameters. And some books you will find that capital VB divided by capital IB keeping VC equal to 0. This is not at all different. Both the concepts are same. And these are all HIE, HRE, HFE and HOE are the hybrid parameters for common emitter amplifier. Let us draw the hybrid model, H model for common emitter amplifier. As we discussed, as we understood, as we drawn the common hybrid model, general purpose hybrid model, V1, I2, V2, there was HI, HRV, HRV2, HFI1 and HO there. Similarly, for common emitter, see that what is V1? VB. What is V2? VC. What is I1? IB. What is I2? IC. Then what? This is HI. What we have written? HIE. What is there in hybrid model? HRV2. This is HRE into V2. What is V2? VCE. Similarly, output IC is divided into two parts, HFE-IB plus HOE-VC. What is HFE-IB? This is nothing but current dependent current source. So see that we have we have included one current dependent current source, which is, this is the part of collector current which is depending on the input current IB. We therefore call BJT as a current control device, because you can see that the most important parameter, most important factor in the output is current, which is depending on input current. We know that FET is a voltage control device and BJT is a current control device. This can be understood from this concept also. And similarly, what is this? Another part of current is across this 1 upon HOE. What is that current? HOE into VCE. And this is the hybrid model for common emitter amplifier. Common emitter amplifier is most important amplifier used in most of the applications. It is because of, we know that common collector amplifier, when we compare common emitter, common base and common collector gives highest current gain but gives lowest voltage gain. Similarly, common base, it just behaves as the reverse to common collector. In common base, voltage gain is highest, but the current gain is lowest. So we normally don't prefer where the extremities are there. We prefer some high medium values for all the voltage and current gain, which are there for common emitter amplifier. And therefore, this particular model, hybrid model for common emitter amplifier, becomes so important from the point of view of analog electronic circuit, from the point of view of electronic circuit analysis. This is very popularly used in so many applications, right from feedback amplifier to oscillators. Many applications common emitter amplifier has, and therefore we need to. It becomes very important to understand what is the standard equivalent circuit in terms of hybrid model of common emitter amplifier. And this is the hybrid model, simple equivalent circuit utilizing or being drawn on the basis of two standard equations describing the four variables in the common emitter amplifier, where HIE, HRE, HFE and HOE are the hybrid parameters. If you look at the standard values of their hybrid parameters, all these parameters, HRE is normally 1.1K. Generally in the problems, in all the competitive examinations, these values are normally given. If they are not given, the standard values for IC equal to 1.3 milliampere, 1.1K, HRE is 2.5 into 10 to the power minus 4. Obviously, there is no unit. HFE is standard value of HFE is 50. Then this is HOE rather 1 upon HOE. 1 upon HOE is 40K. 1 upon HOE is 40K. HOE is 25 microampere per volt. If you get 1 upon HOE, its impedance value becomes 40K. So these are the values for hybrid parameters for common emitter amplifier. So I hope this concept of drawing the equivalent circuit on the basis of two equations and understanding the hybrid model for common emitter amplifier is clear to all. Thank you.